Okay, in this video I'm going to illustrate how to carry out a one-way Mancova and discuss a couple of possible follow-up options to the Mancova if it is statistically significant. One follow-up option is to utilize univariate tests of group differences on the dependent variables. Another option is step-down analysis. So why do you run a Mancova? Essentially what you are doing is looking for group differences on a set of dependent variables while controlling for one or more covariates. In other words, controlling for other variables that might be related to the dependent variables. Within the Mancova model, the independent variable is categorical. So in other words, it may be nominal, ordinal, or some type of discrete ratio variable. The dependent variables are assumed to be continuous and also exhibit multivariate normality and homogeneity of covariances between groups. And then the covariate in the model is essentially either a continuous variable or a dichotomously scored predictor, which basically it would be a dummy-coded variable. So for our current example, we have 4 variables, and we're going to so let me kind of talk about this briefly. We have data on for 52 individuals. Basically, they are high school students who are reporting on their plans or intentions concerning going to college after they graduate high school. So the plan variable is a categorical variable. It's essentially nominal, and the values are 1, plan to attend college full-time, 2, plan to attend college part-time, and 3, plan not to attend college at all. The self-efficacy and utility variables, this is academic self-efficacy and perceived utility for college. These again are assumed to be continuous, and then we also have a covariate that we're going to include in our model, which is intrinsic motivation, and it is also assumed to be continuous. So in the model we are going to we're basically addressing the question, are there significant differences between those individuals who plan to attend or not attend college in some form or fashion on measures of academic self-efficacy and perceived utility of college for the future. And moreover, we want to control for intrinsic motivation for learning. So in other words, we want to determine if there are significant differences on these the two dependent variables while controlling for intrinsic motivation. So to run the basic one-way Mancova, we go to Analyze, General Linear Model into Multivariate. We put plan as our independent variable into the fixed factors box, and we'll put self-efficacy and utility into the dependent box. Intrinsic motivation is being treated as our covariate in the model, so we'll include this variable here. Under options, generally we ask for displaying means and so forth in various tables after the primary results are presented. We can also ask for descriptives, effect size, power, and homogeneity tests as well. Now, the thing is that one of the follow-up tests associated with a Mancova might be to look at the tests of univariate effects of the independent variable on each of the dependent variables separately while ignoring their intercorrelations. So basically a univariate Mancova comparing group differences on each of these while controlling for the covariate. So and then if we find significant group differences, we might be interested in examining pairwise differences between groups on each of the dependent variables, once again controlling for the intrinsic motivation covariate. You don't have the option of like Tukey's or anything like that through SPSS, but what you could do is click on Compare Main Effects and Bonferroni, and this will give you Bonferroni adjusted pairwise comparisons. Essentially comparing adjusted means between groups for your dependent variables. So we can click on continue. Under plots, we can move our independent variable over to the horizontal axis box and click on add, and then continue, and then click on OK. So in your results, you'll notice that we've got your descriptive statistics. So you have your means for your to attend college groups or plan to attend college groups. Those are higher than the mean for plan not to attend on self-efficacy. You see a similar pattern with respect to perceived utility of college for the future. These means are unadjusted, so there's no adjustment for the presence of the covariate in the model. So that's just something to keep in mind. Next, you have the multivariate test results and also Box's test of equality of covariance matrices. So this test is basically addressing the question of whether the variances and covariances among your variables in each of the groups, when you compare across those groups, are the elements in those matrices equal. So what you are essentially looking for is a p-value that is greater than 0.05 or whatever alpha threshold that you set. Unlike most significance tests where you're kind of hoping for statistical significance, for this test right here, you are not. So in other words, if you find that your p-value is greater than, say, 0.05, that's actually consistent with the assumption being met. So if p is less than 0.05 or whatever alpha threshold that you set, then it would be indicative of your assumption not being met. Keep in mind that this test, just like Levine's test or any other test of assumptions, significance tests associated with assumptions, they all suffer from the same effect of sample size on this significance test that you would have for any other tests like comparing means and so forth. And that is, as your n increases, the power of your test increases. So what can actually happen sometimes is that your Box's test might indicate that you have significant differences in variance covariance matrices among your groups, when in reality you have fairly minor differences taking place. On the other hand, if you have a very low sample size, you may have an underpowered test, and you may conclude that that there are no differences or very small differences, when in reality the differences might be quite substantial. So that's one of the limitations of this test when it comes to using it to assess the assumption of equality of covariance matrices. So at any rate, just kind of based on what we see right here, that we would assume that yes, the assumption appears to be met. So that leads us to feel more confident in our interpretations concerning the effect of our planned variable on the set of dependent variables. So at any rate, so you have the effect of plan. You also have the effect of the intrinsic motivation covariate on the set of dependent variables as well. So you can see just in terms of the effect of the covariate, we can look at Wilks lambda right here and essentially see that yes, there's a significant predictive relationship between intrinsic motivation and scores on the set of dependent variables. Concerning the effect of the independent variable on the set of dependent variables while controlling for intrinsic motivation, we can see here that yes, there appears to be a significant effect of the independent variable on the dependent variables controlling for intrinsic motivation. So just keep in mind when you're interpreting the Mancova, you're going to be interpreting both the between groups effects as well as the effect of the covariate on the dependent variables. You'll notice too that all the test results in terms of the F values and so forth, all this information is exactly the same when you're dealing with the effect of the covariate. When you're looking at between groups effects, you'll notice that the F values and so forth, there will be differences on a number of these table values, and that's reflecting the fact that each of these tests actually provides a different lens for looking at the multivariate effect of plan on the dependent variables. If it were the case that I had only two groups that I was comparing on the dependent variables, then the F values, the hypothesis degrees of freedom, error degrees of freedom, everything would be exactly the same. But given that we have more than two groups, that's where these values will differ. So at any rate, like I said, so if I'm interpreting these results, I would say, yes, there seems to be a significant predictive relationship between the covariate, intrinsic motivation, and scores on the dependent variables. And there also seems to be a significant between-group differences on plan on the set of dependent variables after controlling for intrinsic motivation. So we can actually then follow up the multivariate test with univariate analysis of covariances. So that's what this table now will present. So you'll notice that you've got the effect of plan and the covariate on each of the dependent variables separately. So in other words, unlike the Mancova, which takes into account the intercorrelations among the dependent variables, the Mancovas do not. So as you're interpreting these results right here, we can say the effect of the covariate intrinsic motivation on self-efficacy while controlling for the between factor plan, that effect was not statistically significant. So there was no significant predictive relationship. The effect of intrinsic motivation on perceived utility, controlling for the plan variable, that was actually statistically significant. More importantly are the tests of between subjects effects. So the effect of the independent variable plan on self-efficacy scores while controlling for the covariate, that was statistically significant. So that basically means that there were significant group differences on self-efficacy while controlling for the covariate intrinsic motivation. Similarly, when we compare the two groups on utility while controlling for intrinsic motivation, we see a significant group difference here. So in both cases, we have significant between groups differences on each of the dependent variables while controlling for the covariate in the model. So note too that the Levine's tests that you have printed out up here are basically, they utilize the same rule that we have concerning the boxes test, which is what you're looking for p-values that would be greater than 0.05, suggesting equality of error variances between your groups. And so that has implications for interpreting the between subjects effects with the single Mancovas. So if we scroll down, you'll notice that you've got your group means, grand means for each of the dependent variables controlling for the covariate, as well as the adjusted group means controlling for the covariate in the model. So you want to keep in mind that the Mancovas themselves are actually tests of adjusted group means rather than the original group means that are unadjusted. So the tests, the Mancovas that we saw right up here, where we're testing group differences on self-efficacy and utility, that's testing differences on these adjusted means, or means adjusted for the presence of the covariate, as opposed to the means that we saw earlier, which were unadjusted for the presence of the covariate. So when you're reporting on Mancova results, be sure that you report on the adjusted group means rather than the unadjusted group means. Or at least, or you might provide both, but at a minimum include discussion of the adjusted group means. So scrolling down, you can see that once again, kind of getting back to these adjusted means, you can see that the means for on self-efficacy for both of the plan to attend college groups, those were higher than the mean for plan not to attend college group. So that's for self-efficacy, and you see a similar type of pattern emerge for utility, only that you see a little bit more difference between the plan to attend college full-time group and the plan to attend part-time group. But again, those means are greater than the adjusted mean for the plan not to attend college group. So, scrolling down a little bit further, we have the Bonferroni post hoc comparison. So these are basically pairwise differences in adjusted means. So for self-efficacy, you can see we would just take column I and subtract column J, which gives you the mean difference or the difference in adjusted means between the groups. You can see that there was no significant difference between the two plan to attend college groups on self-efficacy, whereas when you compare the groups on the plan to attend college full-time group and the plan not to attend, you see that there's a significant difference in adjusted means favoring the plan to attend college full-time group. That group scored about 4.766 points higher on average than the plan not to attend group. Then also comparing the plan to attend group versus the plan not to attend group, you can see there was a higher mean or adjusted mean for the plan to attend part-time as opposed to the plan not to attend college at all, and that difference was statistically significant. When we look at perceived utility, we can see once again no significant difference between the two plan to attend college groups. But you do see significant differences in terms of the comparison between plan to attend college full-time and plan not to attend. So you see a tendency to favor the plan to attend college full-time group, and then also when we compare the plan to attend part-time versus the plan not to attend, you also see a significant difference here favoring the plan to attend part-time group. So these were the univariate, these are basically pairwise comparisons of adjusted group means for each of the dependent variables. And this might be one strategy as a follow-up to the univariate ANOVAs that we discussed previously, or univariate ANCOVAs that we discussed previously in this table. So kind of scrolling down, you can see that we have the profile plots for the adjusted means for self-efficacy. So you can see that there's the lack of difference that you see between these two groups, the college groups on this variable. But you can see that when you compare the differences between each of these groups and the plan not to attend college mean, you can see that there's a lot more difference there. And you see a similar pattern emerge with respect to perceived utility of college. Now, so those were basically post hoc comparisons involving essentially paired, looking at pairwise differences on the dependent variables. And another option is to utilize plan contrast. So you can go back through general linear model and multivariate, and you have various plan contrast options available, canned options in SPSS. I really don't like these too much, except for maybe the polynomial contrast option, which I'm not really going to utilize here. But if you want to carry out some type of simple or complex plan contrast at the univariate level, instead of running the post hocs that we just ran using the Bonferroni pairwise comparisons, you can actually use syntax to carry those contrasts out. So what I'll do is I'll click on paste, and essentially it will generate all the options that we requested previously. And